Well, since we can really think of decimals as another number, we can do what we've been doing with numbers in general, and we can start solving equations with them. So, what we want to do is solve equations for x. So, or I guess the variable. So let's look at how decimals appear in an equation. This says if I have some unknown quantity and I add 9/10 to it, I end up with 1.3 or 1 and 3/10. So we isolate the variable by getting rid of that 9/10 on the left hand side. But whatever we do to one side, we do to the other. So on this side, these will cancel. And here I have this subtraction of decimals. So I need to borrow one from here, and that's 0.4. And so we get that our unknown quantity is 0.4. And we can always check by placing that back in to where our variable was and hoping that it equals the quantity we were looking for. So I'll do my addition over here. That's 3, carry my 1, and this checks. Alright, well, we had other things that happen with equations. We can have a coefficient in front of our unknown quantity. So this says if I'm multiplying 17 hundredths, or we can say 17 hundredths of, because of is the same as multiplying, I get a negative 0.34. Well, I want to isolate my unknown quantity, and so to do that, I need to divide by the coefficient. Because if I divide by the coefficient, this becomes 1. Anything divided by itself is 1. But whatever I do to one side, I have to do to the other. So this has become 1, and this leaves x with this division. We know it's going to be a negative number, so we'll take 0.34 and we're going to divide it by 0.17. I have to move my decimal place over twice here, so I move it twice over here. And 17 goes into 34 twice. 2 times 17 is 34. And I have no remainder, so I'm done. X is equal to negative 2. Well, I'll come up and I'll check. So 0.17 times negative 2, and we're hoping it equals negative 0.34. So I'll do this multiplication, recognizing that a negative times a positive will be negative. So 4, carry my 1, 3. Count the decimal places in my factor. There are 2. And so I get negative 0.34, so this checks. And of course, we can get a little bit of everything. I can have some quantity, 2.9 is equal to 1.7 added to 0.3 times my unknown quantity. Again, the game is to isolate the unknown quantity, and we kind of do PEMDAS in reverse. So I want to get rid of the 1.7 first. Well, to do that, I need to subtract by 1.7. But whatever I do to one side, I do to the other. So I'll come over here and I'll do my subtraction. So I get 1.2. And these cancel out because we did that on purpose to get rid of it. And now I want to do a division of whatever coefficient is in front of x. And so that leaves me with x equals, and I have to come over here and divide 1.2 by 0.3. So I move my decimal place over, and I move my decimal place over. I have to move this 1, and this needs to match it. 3 goes into 12 4 times. And so my unknown quantity is 4. Well, let's check that back in the original thing. So I'll put 4 in place of my variable. Now I have to follow order of operations, so 4 times 3 is 12, but I had 1 decimal place there, so it becomes 1.2. At 1.7 plus 1.2, 7 and 2 is 9, 2.9. And so it checks. Let's do one more. And we'll get some parentheses thrown in here. We'll make sure we get all of our order of operations taken care of. So I have 6.3 minus 5 times an unknown quantity is equal to 3 times the quantity, x plus 2.9. So we need to get this distributed through so that we can have kind of all our variables isolated. So I'll do my distribution. 3x plus, well, I need to multiply 2.9 by 3. So that's 7, carry my 2, 8, add 1 decimal place. So 8.7. Now I want to get all my variables on the same side and all my numbers on the same side. Well, I think I want to keep my variables positive. So I'm going to add 5x to both sides. These will go away because I'm doing that on purpose. These will combine because they're like terms. Now I need to get rid of this 8.7 because it's in the way. So I'm going to subtract 8.7 from both sides. Right, whatever I do to one side, if I'm getting rid of that by subtracting, I have to do it to the other. And so these will go away. So I have 8x, and now I just need to do the subtraction. Well, I'm taking a bigger number away from a smaller number, or I could think of it as adding the opposite. But what I do know is my number is going to be negative because I'm subtracting a big thing from a smaller thing. So I'll do my subtraction this way. 4, 2. But I know it's going to be negative, so I get negative 2.4. And now I need to divide both sides by 8. So 2.4 divided by 8. Well, 8 goes into that 3.3 times. 3 times. With no remainder. So I've canceled that. And I have x is equal to negative 0.3. And if you go through, you will see that it checks. And so our decimals work like the other numbers we did in equations. And they give us the ability to work with things that are more like what we measure. Decimals are really useful for when we are measuring things. And what we're going to look at in the next video is some special operations we do on numbers where decimals get used a lot. And they're the mean, median, and mode, which are ways of looking at data. See you in the next video.